Hello again. Today we're going to go through another interview question that's popular on these coding websites that train you up for algorithms and how to solve programming questions. Today we're going to be going through the missing element algorithm, and we'll be using the EXO uh, way to solve the problem. Now, it's just simply you have an array with um, each array element or index is numbered from 0 to n, and you basically have to find the missing element. So it goes from in this case we're going from 1 2 3 4 5 6 7 9, so we're missing element 8 here. In the XOR, if you don't know what XOR is, XOR just finds the difference between bits. So if you have 0 and 1, it's going to return true or 1. And if you have if the bits are the same, it's going to return false. Right? So XOR only returns true if the bits are different. And how the XOR works, like say for example, this array here, if we XOR the entire array, you have to go through it one by one like this. It's 1 XORed 1 XORed with 0 gives you 1, XORed with 1 gives you 0, 0 XORed with 0 gives you 0, 0 XORed with 1 gives you 1, 1 XORed with 0 gives you 1 again, 1 XORed with 1 gives you 0, and 0 XORed with 1 gives you 1. That's how it works. And then you can go through each column and get your result that way. Don't forget, it carries forward. So 1 XORed with 0 gives you 1, and that 1 has to be XORed with this one. The result has to be XORed, and so on and so forth. So that's how that works. XOR works. All right, we are going to. All right, so we're in the Python shell. It's a really convenient place to demonstrate how the XOR works. So let me just clear up some stuff here. And really quickly, I can show you what the result of the first array would be. So we have 1 XOR 2 XOR 3 XOR 4 XOR 5 XOR 6 XOR 7 and XOR 9. Let's save that in a variable. Let's call that variable I. Alright, now the result is saved in I. What's in I? I is 9. So as a result of all that XORing, we have 9. And let's XOR the full array. The full array would be 1 XOR 2 1 XOR 2 XOR 3 XOR 4 XOR 5 XOR 6 XOR 7 XOR 8 and XOR 9. Let's put that in a variable. Let's call that variable J. Oops. This should be 9. All right, so the result of this, let's see what J is 1. So finally, to get the result, we have to XOR those two results. So we XOR I XORed with J, and that should give you our difference. And there it is. So the missing element is element number 8. How do we do this in a program? In the program, we're going to just use for loops to do it. Like you see here, we have our our array with the missing element. Then we have the full array. I just put it here so that you know we don't have to put it there, but I put it there so that you can see what we're doing. Then we're going to have the result of XORing our missing element array, and we have the result of XORing the full array. So here we put it in a for loop. We get the result. It's our array XOR equals whatever is in array XOR XORed with X. So we're going through it in a loop fashion, each element, and we're just XORing it out. And again, we do it with the full array, and then we XOR both of the both results. All right, let's run that and see. I have the missing element, and there you have it, 8. It returns 8. So that's simply how you use XOR to find the missing element in an array. And sometimes, don't forget, just a reminder that XORing is commutative. So even if you put 1 XOR 2, so basically 1 XOR 2 is the same as 2 XOR 1, right? It's the same. So it's commutative. All right, let's go back. There's another twist to the problem, and that is to find the unpaired number in the array. So you go through an array, you have paired numbers in the array. In this case, we have 2 8s, we have 2 2s, then we have a 5, then we have 2 3s, then we have 2 7s. Again, it's commutative, so the order doesn't matter when you're doing your XOR. To find the missing number, if you look carefully, remember I said XOR finds the difference. It rings true. The result is true if the number is different. If the number is the same, the result is 0. So binary 8 and binary 8 would result in a 0. Binary 2 and binary 2 would result in a 0. Binary 3 and binary 3 would result in a 0. Binary 7 and binary 7 will result in a 0. Then when you finally XOR the resultant 0 with 5, 0 XORed with 5 will return 5. So 5 will be the unpaired number. All right. And again, it's commutative. So it doesn't matter the order, how you go about it, and I'll prove it to you. So we have, let's find the unpaired number. We have 8 XORed with 8, XORed with 2, XORed with 2, XORed with 3, XORed with 3, XORed with 7, XORed with 7, XORed with 5, should return 5, and that's what it did. Let's mix it up the order. 8 XORed with 2, XORed with 7, XORed with 5, XORed with 8, XORed with 2, XORed with 3, XORed with 7. We got to make sure we get this right. So 8, we have 2 8s, 2 7s, and XORed with 3 again, XORed with 3 again, and we get 5. So it's commutative, so it doesn't matter the order you put it in, the result is always going to work out. All right, I think that's it for this question. If you have to do this in an Okay, so really quickly, let's just find the unpaired number. Let's change one of these. We don't need this anymore. I'm doing this in Python, by the way. And let's do 8 XORed 7 XORed 8 XORed 7 XORed, I'm sorry, 3 2 3. We need another 2, and we need the 5. Okay, we don't need this one. We're not using that anymore. We don't need this either. Not using that. So we're just gonna go through it, and the result should be 5. Right. So we're gonna print out the result. We don't have to XOR with anything. We'll print out that result. All right. Let's go here again. Python. Yeah, I'm using the same missing element name, but I changed the program up. So, and there it is, 5. So 5 is the unpaired number. That's how you use XOR to solve these two problems. It's short and sweet. Thank you very much, and have a wonderful time coding.